Hi, welcome back for section 2.3. In this section, we're going to learn about what are called Venn diagrams. So, in general, a Venn diagram is a tool that's used to visualize and organize sets and set operations. So, when we're drawing these diagrams, they are pictures. What we're going to do is in the diagram, we're going to have a rectangle, a large rectangle to represent our universal set U, so that's sort of the everything that's being considered. And then inside of that, we're going to put different circles that represent our various sets. So being inside of a circle means that you are an element inside of that set. And what we need is those circles to overlap properly so that we can have all of the different regions to represent all the different possibilities of where an element could be in relationship to the different sets. So there's two different options that we're going to use. We're only going to draw Venn diagrams for either 2 sets or 3 sets. You can draw them for more, but the pictures get a little more complicated. What we're going to do here is I'm going to show you what those generic Venn diagrams for those 2 situations look like, and then we're going to practice some examples of how to use those Venn diagrams. So for 2 sets A and B, we're going to start with a large rectangle, which is always how we're going to start a Venn diagram, and we're going to label that rectangle with a U, because that is the universal set. So that's sort of everything that we're considering. And then I need 2 sets in here. I need a set A. So we're going to draw a circle and label it with an A. And then I need a set B. And we're going to draw them in such a way so that they overlap one another, so that I have some of the portions of the circles overlap and some of them are distinct from one another. So that's our Venn diagram for 2 sets. If I have 3, then again, we're going to start with a large box or a large rectangle, label it U for the universal set, and this time I need 3 circles, one for A, B, and C. Obviously, those names of those sets could change. You could use whatever set name you need for the example that you're in. But again, what I need in this one is I need all 3 of them to overlap, and we need them to overlap with one another. So what we're going to end up with, we'll have 1 circle to start off with for set A. We'll have a second one for set B. So far it looks just like the Venn diagram for 2 did. And then I'm going to put a last third one towards the bottom here for set C. So what we can see is any 2 of the circles, if we just focus in on those 2 circles, it looks just like the Venn diagram for 2 sets did. If you kind of see in the middle here, if we did it correctly, we should end up with kind of a little, it's like that trefoil knot or the Trinity symbol in the middle. You could rotate that whole thing, obviously, if you need, but those 3 circles need to be there and those overlaps need to be done properly. So that's our Venn diagram for 3 sets. One of the first things that we're going to use Venn diagrams for as an application is these different regions. Each region represents a collection of elements that relate to the different sets A and B or A and B and C in different ways. So the regions help us visualize our different set operations. So let's see, for example, I could draw a Venn diagram that represents the set of A intersect B. Now what we would need to do is we would need to start off with a Venn diagram that always starts with a box labeled with a U. Now in this one I could think about, do I need 2 circles or 3 circles? It would not be wrong to put 3 circles in it, but really I only need 2 because I only have an A and a B. So I'll draw 1 circle labeled A, overlapping with a second circle labeled B. Now what we're going to do is we're going to shade in regions that would represent the set of A intersect B. So what we need is we need to think back to our definition of intersection, of what did an intersection mean. Well, remember, intersection, like a road intersection, is the overlap, right? Where do those things overlap and have common elements with one another? Now, notice, visually, we literally made the sets overlap. That's not a coincidence. Notice what we're going to do is the intersection is right in this middle portion, because by definition, it was elements that were in A. Notice that portion is a part of circle A, but also in B. So that portion is a part of circle B as well. So this middle region represents elements that are both in A and in B. As opposed to outside of that region, look, we would be in A, but we are outside of the circle B. So literally, it's this visual representation that to be an element of a set, to be in it, you literally need to be in the circle, in one of the portions of the regions. That's probably the Venn diagram that we would have chose for that. If by chance we had drawn 3 circles in our Venn diagram, like I said, it's not incorrect, but it's not entirely necessary. However, it might be helpful to see what it would look like, just so that later when we're working on problems, we don't get hung up by thinking about this. So I've drawn a Venn diagram with 3 circles. Now again, we need to think about being in A and in B, in both of them, in the overlap between the two. So essentially, the circle C just doesn't matter. Whether or not I'm in C doesn't matter. So I still need the full overlap of A and B. So the shape of that region that I shaded it fully in that one just so that you could really see it. Didn't change from when we only had 2 circles. So notice, there's part of it that's in C and part of it that's not in C. That part doesn't matter. It still is A intersect B. So likely, if this was all you were asked to do and you didn't have a Venn diagram to start with, you would draw that first one. If you were given a Venn diagram that already had 3 circles in it, you would have to interpret it as the second one. Now let's try and go the other direction with this. So let's start with a Venn diagram and try and think about what the shaded region would represent. So we're starting with this next example, and we notice all of circle A is shaded along with all of circle B. So we've taken all of the elements of A and combined them with all of the elements of B. So we need to think about which of our set operations that seems to be most closely related to. Now remember, when you took all of one thing and joined them with all of another thing and lumped them together, that was what we defined as a union. So this one is A union B. So literally, A union B, when you draw it in a Venn diagram, you just shade both. So you shade in either the things in the one circle and the things in the other circle. You should combine them together, right? Think about that type of a word, joining or combining for a union. Now let's try one with 3 sets. So let's try this guy over here, A union B union C. So first off, we recognize that, well, we'll need a Venn diagram, which always means start with a box, label it U, and then we can think about how many circles do I need. Well, I have an A, a B, and a C, so I do need all 3 for this one. Make sure that we do label them because it's important which one is which. So label 1A, 1B, and 1C. And then we think over there of what this means. So unions, just like this previous example we just did, says join the things together. So shade anything in any of them. So anything in A gets shaded. Anything in B gets shaded. and anything in C gets shaded. So essentially, in this picture for A union B union C, everything in all three of the circles is shaded. The only thing that's left unshaded is the box, which would still represent particular elements, but they are not included in A union B union C. What we're trying to do is we're trying to, like we said, we're putting these visual pictures to the set operations that we learned in the previous section. Go ahead at this point and you'll grab your worksheet for section 2.3, and we're actually going to do the first two questions. We'll do them both together. So you can try both of them and then log on to the next video and take a look at the solutions for both of those problems together.